Hello, my name's Ryan, and we are back again with another wacky physics video. So today what we are going to be doing is this problem right here, which is we have a 40 kilogram ball that's hanging from this rope from two other ropes shown here. One rope is tied to the wall and parallel with the ground, that's T3, and the other is tied to a ceiling and angled 45 degrees from the horizontal. And we have to find the tensions in each rope. Now, before we start this problem, we have to ask ourselves, what do we know and what do we not know? Well, we know that there is a 45 kilogram mass hanging from this system, right? And we know that T2 is at a 45 degree angle. And with that knowledge, we also know some physics, or at least I do, and you're going to learn some physics. And what we don't know are the tensions between all of these ropes. Now we can find that very easily. But first what we're going to do is we're going to set our reference point to be the middle of these ropes right here, because it makes things a lot easier, as you'll see in the next little series. So first things first, we draw our system, our force system. Now this whole thing has to equal to 0 because the system isn't accelerating. If there's no acceleration, there's no force. Now with that being said, T1 we can already figure out is going to be equal to the force of gravity times the mass, the acceleration of gravity times mass, because this 40 kilogram ball is the only thing acting on T1 that's pulling it down, right? T1 is being held here by the force of gravity acting on this ball, so we can find out that mass of gravity times negative g is going to be equal to T1, which is going to be equal to 441 newtons. I'm sorry I worded that terribly, but I hope you understand what I mean. Now, because we set our reference point here, it was very easy to find T1, and now that we have T1, we can figure out T2. Because T2 is at a 45 degree angle, it has a y component to its force, its tension total here. And we can figure out that y component by doing a little bit of trigonometry. So what we can say is that this is our T2, and we can figure out this y component by setting it as the opposite. Our T2 is our hypotenuse. We can say that T2y is going to be equal to the hypotenuse times the sine of 45, because sine is equal to opposite over hypotenuse. Solve for opposite, and you get this equation right here. Solve for it, you get 623.7. Easy stuff. And this number right here, this number is going to be equal to this guy right here. So that means that, what that means is that 623 newtons of force are being pulled right here in order to balance out this y component of this T1 right here. Or in other words, this T2y is equal to this T1, which is equal to 441. Now, we need to solve for our x here, because our T3 is the only other thing acting against this T2 x component, right? And the way we do that is by taking the cosine instead, which is what we do here. So T2x is equal to T2 cosine of the angle. That'll give us this bottom little length right here, and we can set this equal to 0, right? F net, which is the net force acting on the system, is equal to 0 because the system isn't accelerating, which is equal to T3, which is this guy, minus that x component of the T2, which is T2 cosine 45. We can solve for T3 because we subtract T2 on both sides. We get T3 is equal to T2 cosine 45. Plug in our knowns. T3 is equal to 623.7 times the cosine of 45, and we figure out that T3 is equal to 441 newtons. Now that we know all of the tensions in the rope, that concludes the solving process for this problem. We have a T3 of 441 newtons, a T1 of 441 newtons, and a T2 of 623.7 newtons. Thank you, and if you like this video, like, comment, and subscribe, and I will see you in the next video. Thank you.